sometimes too.
Okay. It should now be working. Oh.
Hey, can I get some confirmation in chat that we have audio now?
Yeah.
Sorry if we've been running it without audio.
Do we need to go back and restart it from the start?
Yeah, I see some levels. It's okay. Yeah, we'll start over, guys. So, welcome.
Alright, so we're back to the start.
Hi, this is Carson, and alongside me we have Bernard. We are two of the members of the University of Houston Drone Pilots Club, and today we are going to be building a 5-inch drone and teaching you some of the tips and tricks on how to achieve it, and demystifying it hopefully for y'all. I'd like to start off the build by just kind of going over the materials that we're going to be using today. And it's a mostly complete build list, so if y'all would like to go and build this yourselves, you can see the price there as well and links, and we'll try to get those links in the description for the YouTube video later on as well. The frame that we're using is a carbon fiber frame. The name is Stark. There's a lot of names for different drone frames, but as long as you get a carbon fiber one, the right size you're looking for, you're good to go. The motors we're using are 4 of the Xylo Stealth 2206 2600 kV motors. Those numbers seem a little foreign. What do they mean? The 2206, the first 2 numbers, is the width of the motor, and 06, the second 2 numbers, is the height of the motor. And 2600 kV tells you how fast it spins. It rotates 2,600 rotations per volt. So as you add more volts, it'll spin faster. Now, what's powering these motors are called ESCs, and it's a 4-in-1 ESC. So in the hobby, there are 2 different ways to do it. 4 individual ESCs, or you can do the 4-in-1, like this guy. So all of them right there. And it's by T-Motor. Pacer is the type, and it's a 50 amp ESC. And to go along with that T-Motor Pacer ESC, we have also a T-Motor Pacer flight controller. It's an F7. I recommend F7s if you guys are looking to build a high-performance FPV drone. And now that I mentioned that, let's explain what an FPV drone is. There are drones that just hover around and take pictures, but what an FPV drone does is it puts you in the cockpit by wearing goggles and seeing what the drone sees, or you could use a standalone screen. Yeah, I have an example of a fully built one here. Find the camera, yeah. So, yeah, we build these ourselves usually, save cost, and helps us when we need to repair it or upgrade it with better electronics. So we like flying fast and having fun racing and freestyling with them.
FPV drones are really good when it comes to high speed and awesome videos. If you're trying to build autonomous and other stuff though, all of the stuff is the same. So your motors will be the same, your frame will be a little bit bigger, but you'll still have a frame, you'll still have a motor, you'll still have everything else that's in here.
Thank you, Bernard. That's a good point. Is even though this is a specific type of drone, that the basics are going to go along with any drone that you want to build. Thank you. And so going back to the build list, the FPV system that we're using is a Caddx HD FPV system for the DJI goggles. It's kind of a new technology over the last year or so, and we'll go into that at the end of the stream, exactly what that FPV system really is all about. Going on, the cool little thing that we're going to do during this build is motor skids, and they're going to have lights inside of them, and pretty cool. So let's go back to the build. Let's just go to the build camera full screen. And when you're building a drone, I recommend it doing in these steps that I tell you. Yeah. So we'll get started here. The ESC, the 4-in-1 ESC is what I'd first recommend to start with. All of these pads here are going to come untinned, so it's just going to be a copper pad with no solder on it. The first step I recommend doing is tinning all of those pads. And you don't see them here because I have it insulated already. Like Julia Childs, I've pre-prepped this build. And But yeah, those are the biggest pads, and you're going to want extra high heat for these high gauged battery wires. I'd also recommend when you're tinning that you remove or don't put on these gummies yet, because you can burn them. Also, a little extra insulation with some tape if you want could help from solder splatters. Once you get all that pre-tinned, I'd move aside your electronics and I'd start working on the frame. Now, reason that we're going to start working on the frame, the reason that we're going to start on the frame is we're going to want to understand the length of wires we're going to need for the motors. How does this go together? You have the bottom plate here, we have our arms going to be stacked on top of that, and then this plate's going to be at the very top. So how are you going to align these? It's pretty hard to mess up. You see these 3 holes here, 1, 2, and 3. You're going to want to line those up with this 1, 2, and 3. And you can even see here on the end they kind of lock together, so it's really hard to mess this step up. And it's pretty common for all of the builds. Let's get a better angle here so you can see me line up the holes. Okay. So yeah, flip it over there. I've got the alignment I want. So this is going to be kind of the most awkward step, because I recommend just starting with 1 and you just kind of have to finagle it just right. So we're going to be using 2 lengths of screws here. One is the smaller one and one is the longer one. The longer one is for your FPV stacks, so include your ESC and my flight controller here off to the side with all the screws. So that one's going to go, not the one most on the side or the one on the outside, but the one in the middle. That's going to be your long stack. And let's just get started. I'm just going to be here building for a while. If anyone's got any questions, put them in the chat and we'll answer them for you. So here is the most awkward moment of the build, I promise.
If you have questions that you're watching after live chat, if you put them in the comments, I will try to answer them, or Carson will try to answer them when we have spare time.
Yeah. Let's get a little up here. See what I'm doing.
Do you need little arms? Or grab your arms?
Oh, I think I'll be okay. Thank you, though. That is not a bad idea, though.
Normally when you're doing electronics, you would want to have that.
Helping hands are great. That's something I do want to mention, is when it comes to soldering, there's a couple of things that's going to make your life easier. Number 1 is lots of heat. Not too much heat. You don't want to like burn your wires up, but you want to just contact just for like maybe a second or 2, and the solder just pool. And that's going to really help you get nice, clean, and shiny solder joints. You see here, I got the first thing in here. And now my whole build's going to be easier because it's kind of held together at least. So,
if you're more curious about soldering and the internals of how that works, the Live will be is planning on doing a workshop in the future on that. So stay tuned. I will probably be the one hosting that. So if you have questions, let me know. Yeah,
going back to my quick tips. Second thing I recommend is some flux. When you're tinning your wires, you're gonna come just with some. You're gonna be cutting your wires a lot basically, and you're gonna need to strip them and tin them. And I recommend, it's kind of like a little paste that you put on the ends of your wires that really helps that solder wick in there. Let's see, what did we do here? Just a little off somehow. That's another thing I recommend. Don't try to get your build just too tight, because then your holes are not going to line up just the way you want them. Yeah. Did I mess it up? Yeah, and that's the thing, like if it doesn't fit, then you're doing it wrong.
I'm surprised there's not a build instructions for it.
Yeah, that's the thing, is when you're going to build a carbon fiber frame, they're really not going to come with instructions anymore. You'll be lucky if you find a YouTube build tutorial for that specific frame you're looking for. Those will help. But like I said, it's almost like intuition. I put it in wrong. It's not going to work. Yeah. Yeah. So you see, it has more of an angle that way. So this is going to get us the right. Yeah, that's what we're looking for. And so we'll also, one thing I'm going to do is, you see that little triangle looking thing, I'm going to match that up with this as well. Alright, now this build is going to go by so smooth, and we'll be installing electronics in no time. So one pro about a carbon fiber frame is they're both light but rigid. I've seen a lot of comments in our Discord already, and just in general on YouTube, of people wanting to build drones out of maybe 3D printed parts or wood. I would just recommend going carbon fiber. Maybe in the past, when frames cost $100, I'd say maybe look into maybe a wooden drone for your first one, or a 3D printed drone for your first one. But that's the big thing, is your first drone you want to have a success, and you don't want to get discouraged. And honestly, I feel like you'll just get discouraged if you fly anything else.
You can find $10, $20 frames on Amazon for most types of quadcopters, including autonomous ones. An FPV frame will probably be around $40. That's what you should, roughly $40 to $60 that you're spending on it.
And I don't want to discourage people from expressing your creativities and builds. If you want to do something original, go for it. But if you're looking to get into it cheap, and the frame is something that you cheap out on, that's the wrong way to go about it. Well, actually, yeah, these days, you know what I mean. Just don't buy a carbon. Don't buy something that's not carbon fiber. Yeah, I'd say even for large drones, you're going to want to. Can I do it again? I swear. This talking and building thing isn't. That's probably why.
Almost all frames on the internet right now are all carbon fiber, because carbon fiber is so good weight-wise. The only ones that aren't carbon fiber I can think of are fixed-wing aircraft, because they use EVA foam. But
yeah, I'm just doing the same thing. You wanna?
Oh, screw.
Hey, there's Bernard. We'll get back to the stream in a second.
I'm monitoring on a fortune cookie.
Oh. All right, we'll swing back to me here. Okay. So yeah, here on this build today, we're going to have wiring diagrams to explain the connection strategy that you should go about, because it can get daunting and confusing. But those wiring diagrams just make it so simple. So yep, right now it's just going to take a while because I got to do everything 4 times. So.
On that note, are there any questions from anyone?
Yeah, shoot some questions in the chat if you got one. You got any people viewing right now?
I can check.
I like how that guy asked if we started yet. There.
It's John. He's in the chat. Let's see. Participants. Oh.
No one's here.
No one's here. Awesome. Big sad. Well, usually people watch it afterwards.
Yeah.
Yeah. Because last video we had 2 people watching the stream, and then 28 people actually watching it later. So.
Yeah, and you can see here. Let's bring it back down. I got goofed twice on this frame already while I've been trying to talk to y'all. So you can see here, not the right orientation. Bring it up there. That's alright. Did I do it wrong again?
Breathe.
Yeah. See, that's how tough it is. This is the orientation. see if I get that angle.
There's some really nice folding props.
Yeah, that's going to be an exciting part of the build. Is we're going to check out some folding props, y'all. Kind of a new technology as far as the drone world, but folding props have been around, you know, since helicopters and all that, RC helicopters. So, you know, it's actually invented by one of the guys from Rotorite.
Really, the prop folds?
Yeah.
Really?
This guy that has like the auto shop and does a lot of the home build stuff.
Oh, I know which one. It's not Streeple, it's the other one. Streeple's a different YouTuber. Oh god.
Where are my Streeple people at, huh? Anybody a Streeple head? Anybody?
Is that what he calls them now? Streeple heads?
No. I think Streeple people was a thing at one point.
Yeah. I think I still got that t-shirt.
Let's bring it up a little bit so you can chop. But yeah, shout out to Peter Streeple and the electric plane build he just did.
Okay. Sure.
Oh, you're trying to check out the folding props, huh?
Yeah, I'm just putting them together and taking them apart just to see what they're like.
You won't believe it.
The only problem is the folding props are so expensive, and they actually reduce a falling drag, which is a problem. So if you're doing a flip upside down, the actual falling drag changes.
Yep.
Yeah. Because I'm terrible at it. I even noticed it when I had the Dalpop folds.
Can you believe it? Three times in a row? Put the arm in the wrong way?
Breathe, cousin, breathe.
So that's...
Yep. Oh, hey, Robert.
Hello.
Robert is the FAA.
The government is watching.
Yeah.
Everyone.
Free Weather Agency. Ah, here's the laptop. Okay.
So right now we are putting together this frame of this 5-inch FPV drone. Just off screen we have all of the electronics pre-soldered, and I will go through the connection strategy. Alright. The one positive about the arms now is it will only lock into place when you have 4 of them. At least that's my hope. Yeah, that's wrong. There we go.
No, he's a friend of mine. We're doing a workshop together.
So yeah, this stacking strategy is pretty standard nowadays. Okay, yeah. This stacking strategy is pretty standard nowadays with the bottom plate, arms, and then this little sandwich plate right here. An interesting thing about the sandwich plate is it comes with like these self-locking nuts inside the frame. Hey, what's up, Emo?
Hi, Bimo. How you doing?
So yeah, any point in time you'll have some questions, put them in chat. Here we are with the build. We're almost finished with the frame. We're on the last arm.
curious how many people are actually watching now. Because I'm curious. 4 people are watching right now.
Alright. So, can you put my build in small screen and let's go over the build list one more time for these people? So we
slide. Yep, we can do that.
Oop, that is the wrong screw.
Yep.
Yeah, so today we're going to be building a 5-inch drone consisting of these parts here.
Look at the one up your back.
So we're going to be posting these links later on in the YouTube videos, so y'all can check back later, and if you want to build this yourself. I'll quickly run through them one more time. We have the frame, which is the Stark. It's a carbon fiber frame, which I just got finished building the bottom of. So, swing it on over here is going to be our electronics. We have our motors, which are the Xylo Stealth motors. Can't focus, yeah. Stealth motors there. We got the 4-in-1 T-motor ESC. So ESCs can either come 4-in-1 or 4 separate ESCs. The flight controller we're using goes along with it. They're both Pacer by T-motor. So these will connect nicely, and it's an F7, which is nice. We're using the Caddx Vista Fpv system, which is exciting. This is my first time I'm putting this into a build. It's an HD video link for your FPV goggles. And something fun is, you'll notice here we have these little race wires, and these little things dangling off of them is LEDs, and we'll have these motor skids on the bottom, which will be really fun. So now that we've first step was tinning this ESC, and now we've assembled the frame. Next is you're going to want to place your ESC onto the frame. So strategy of which side is the front and which side is the back. You'll notice here that there's these little brackets here. This is what they call this mount is for what they call a K plate, which is for your camera. So your camera mount's going to be like right here. So you know that this is the front of the drone and this is the back of the drone. Thank you. Oh, I got the K plates right here to show you. Yeah, it's got a pretty cool little signal, so you know which side is which. But yeah, so it's going to go in like that. So that's how I know that this is the front. Now, how do I know which way is the front and the back on this? That's a good question. We can go on to the next slide and we can answer that. Alright. Perfect. So here we have motor orientation. I pulled this off of my what do you call it? Betaflight, yeah. It's a Betaflight orientation for the motors. So, like I said, this is the back of the drone and this is the front of the drone. And you can see there with the arrow which one's the front of the drone there. So this is motor 4. Here, let's see. There we go. So, this is motor 4, motor 2, motor 3, and motor 1. And one thing that you're going to want to do is cross-reference it with your ESC connection. So this is the ESC connection diagram. This came with the drone, or with the ESC for the drone. And you can see here that these are going to match the same motor configurations. So next step that you're going to want to do is you're going to mount the motors.
You might want to point out the fact that usually there's a marker for which way is front and which way is back. Typically, power is going to be on the back side.
Yeah.
But that depends again on your ESC. And if you are buying a new thing, check the documentation. Like, they'll have a manual most of the time. Check that and it'll show up there. And
I want to show you one other wiring aspect you can do. This is a build of mine. You can see here, this is the ESC underneath. This would normally be facing forward, but it's facing sideways. This is just for a cleaner build, It's going to be hard to see in here. Yeah, it makes for a slightly cleaner build, and you can go into the ESC programming, which is called BL Heli, and you can configure what connection goes to what motor.
But most of the time it'll default be running the diagram that runs standard. So if you have a problem with it in your build and it's not flying the right way, Betaflight will recognize that when it spins the motors and it doesn't move the right way, Betaflight will recognize that the motor ESCs are reversed. I know that because it happened to me. It'll warn you, and all you're going to do is the easiest way to do it is just be to go back and flip it, and then try again. That'd be the easiest solution.
Ah, maybe? Okay.
So once you get that all sized up, and once you get your wires cut out to the right length, it's about time to start assembling the motors in?
No, you want to put your motors on the frame first, and then you're going to talk about the wiring. That's usually how I go about it. This is going to be a little bit more awkward than it. So this is why I recommend it in these steps. Don't put all your electronics like I did on first and then build your frame. That makes it a little bit more awkward. Okay. So these screws that we're going to be using now are 2.5. So switch out the tool. And these screws here are steel compared to the aluminum screws that we're going to be using on the rest of the build. A little bit more durable for the motors. So yeah, I'm assembling the skid part. Here. I'll try to get a better angle for you for the next.
Looks like in here. Okay, good.
Great. Here we go. So once again, repeat the same thing 4 times. Let's get this in frame. My bad, guys. Okay. So, I have a tip for you guys. Hold on, we'll tell you the tip in a second.
Okay.
The tip I have for you guys is when you're constructing mechanical things, a lot of you guys might already know this, but when you screw things in, you're going to want to do it on a star pattern. Helps let the stress not build up on one side of the thing. And just kind of loosely tighten them when you're getting them together, and then come back in and tighten them all up. Another thing that's probably smart is Loctite. Basically, you put a little dab of some blue stuff, never the red stuff. Don't use the red stuff unless you're working with engines. But you use the blue stuff, just a little drop, and you screw them in, and it's going to tighten down your stuff. I personally don't use them that much anymore in my builds.
I do, but only in occasions where I've hit it and it's crashed and I have to go back and rebuild it. It's safer to not use Loctite first, and then if you're starting to get a problem where, okay, I think I'm losing screws, so the screws are coming loose, then sticking in Loctite.
And a couple of things about Loctite is it's only metal on metal, never used when the screw's going into plastic.
Yeah, the audio is kind of bassy, Striker. That's kind of the mic that it's designed around isn't pretty. It ain't great, but it's the best we got.
It might have been when he muted them for the audio.
That too. Yeah, that might have also been it. Because the library is shouting at us.
Okay, so let's go through this step one by one, what we're doing here. So you'll see that there's an indent where the LED can go inside and a place for the wire to come out of it. So this is going to be the bottom of the skid. This goes onto the plate there. And so we're just going to fit this LED right inside there, like this. And then we're going to line up the holes with the skid, frame, and the motor. A little awkward when you got a whole bunch of wires coming off of it. Okay. Oh, you know what? That might help our build a little along too. One quick tip. You don't always have to put all 4 screws on your motor. I know this is going to sound weird, guys, but you can get away with 2. Actually, the build I had was flying 2 for a long time, and I just put on 4 today.
The problem with me is that every time I crash, it comes a little loose. So one time I was flying, and then the screw just came out on one of them, and I just went, well. So after that, I've been very cautious about putting all 4 screws in and not tying them.
Yeah, having a motor come loose in flight is never fun. It's happened to me a few times. Now I'm going to remove 2 of these because this is going to make her build go by faster. And we're getting close to the fun part, I swear, guys. Connections. But yeah, if anybody's got any questions, feel free to ask. Oh yeah. Now we're smooth sailing. Okay.
Oh, we have to mute the audio again. Stand by.
So if I have officially lost it, there is one more. One good thing about this, the Stark, here's the frame, the box that the frame came in, the Stark FPV frame. Yeah, all this stuff came from Fpv Crate, by the way, which is a subscription service, kind of like, I'd say the wrong one. What were they called?
Loot Crate.
Loot Crate, yeah. I've been watching too much Red Letter Media. I would have said Geek Box or something. Shout out to Red Letter Media.
Today's drone build is brought to you by, oh God, what is the one that does meals?
Oh, yeah.
Food one.
Blue Apron.
Yeah, there we go.
Today's drone build is brought to you by Blue Apron.
Officially, we are not sponsored by Blue Apron Loot Crate. Which one is this one?
FPV Crate?
FPV Crate or any of the other loot box companies. Gotta say that so I don't get my butt kicked. UH legal.
Hungry after a busy day.
I mean, if they want to sponsor us, Loot Crate wants to sponsor a tiny student organization in the middle of UH. We're happy. That'd be fun. I'm just curious to see this.
Yeah.
I've not seen the I've seen the bigger here. I've not seen the tiny one.
We are going to have some fun with the Dji Fpv system because we are going to swap cameras on it today. Believe it or not.
That's gonna be annoying.
Yep. But it's going to be the only way with the size of K bracket we have to go up one camera size. And that camera size is still too small, but we're going to make it work. That was I was working on that this morning, figuring out what we're going to do to mount the camera. Small gripe, sorry everyone, but what are you doing, Cadix? The camera that they made has one hole on each side. What are you supposed to do with that? You want your camera to be mounted solid. You don't want just a hinge where it swings back and forth every time you crash. So
you're copying Foxy, and Foxy did it that way, so then it must be good.
I don't know how you guys mount your Foxier cameras.
Foxy Predator comes in one screw on each side.
How do you mount it?
I glue it to it.
You see, no, you need to screw in your cameras. In my opinion,
I screw it in and then I glue it, basically to a 3D printed frame that would move up and down.
Because you want your camera not to have any vibrations. You want it to be lock steady. People used to, back in the day, fight the vibrations like crazy, but now that's what this thing does. This is your flight controller, which is basically the brains of the drone.
It's also kind of important to have it locked to your frame, so that way if something goes wrong, it'll recognize, hey, there's something very wrong here, and you'll be able to feel it when you're flying.
So here we go, guys. We have now put the motors on the drone. So this is the point where I'd recommend the step-by-step on how to solder these on. Yeah. Let's go to the wiring diagram for the, there we go. So you're going to want to lay this race wire down, is what they call it. Well, what is race wire? What's the point of this? All this does is it protects your motor wire from a propeller strike. When you're flying, here, I'll bring out my analog. When you're flying, see, mine doesn't have it. I'm in danger. And if your prop, here, let's get one of these. If your prop bends down when it crashes, it's going to rub and it's going to break your wire. So what this does is the prop's going to bend down and it's not going to hit those. And it's not going to break the wires. It's just going to scratch this little thing here.
And it's an optional add-on, so it depends on if you want to or not.
Yeah.
They're usually like $5 to add. So it's
more soldering work, but it saves your build. And you want to know a little cheat around that. Take one of these propellers, cut it off, just one blade, and you're going to tape the blade over top of this part, and it'll do the same thing. That I learned from Mr. Steele. Shout out Mr. Steele.
That's an old trick though, right? That was in his older videos.
Yeah. 2018 build.
No, that's not too old. Considering I'm still flying an F4 from 2017.
Switch back to this. So yeah, now back to the wiring. So these three wires connected to the race wire and then to the ESC, the electronic speed control. And what those little wires jutting off there is a DC line for some LEDs. So if I am correct, as the motor throttles, it'll, yeah, you can see there that it operates between 5.5 volts and 20 volts. And, yeah.
So, in your motoring diagram, so each three of these pins here will be attached to a motor. So these three would go here and these three would go here. Race wire goes in the middle of that to make sure that it protects it. So the wire are parallel to each other, if that makes sense.
Yep. So strategically measure from there, and then you're going to cut off the X because these motor wires are going to be long, about like from there to there. So you're going to cut off the excess, and you're going to use your excess and measure up over here and get the right length on there. And once again, don't go too slow with your solder where you're just going to burn stuff up and mess up your solder joint. You want to be in and out. You get semi-decent joints like mine. Okay. So, next step comes the flight controller, excuse me. And how we connect the flight controller to the ESC is through this plug here. I don't know if this will pick up on the camera. Oh, come on, pick up. But what it says here is FC.
Okay, bring it up close. Try now. No, it's
That's here.
Yeah.
So on one side of the cable it says FC, and on the other side it says ESC.
So we've got a fine boss.
Oh yeah.
That could work. So
Perfect.
No, it didn't work.
FC, you can kind of see it.
Yeah.
Get out the glare there. Yeah. FC right there, and ESC on the other side.
Yep.
Believe me if you can't see it. Okay, so this is my FC, so I'm going to take my FC pin here. The flat part of the connector goes to the flat part of the connector. Don't try to connect it this way because that's not the way it goes, where you see all the little metal pins. So this comes with your build here, this wire. This will come with your FC. And like I said earlier when we were discussing the parts list, these two naturally come together. So connection is super easy. These days though, a lot of these come like this, so pretty standard. I don't know for sure, but I'm pretty sure you can just connect them. An ESC to one that's not the same flight controller.
You will have to check your wiring diagram.
Yeah, definitely check.
Yeah.
Let's go back to those just to give them an idea what they'd have to look at. Yeah, right there you can see there, highlight the pin there, yeah, you can see all of the different things. One of these main, a lot of them are telemetry.
But most of the time all I gotta do is just check if they match.
Yeah.
So over here where it says the plugs, yeah, so all of these just have to match to make sure that it's okay.
Okay.
If it doesn't match, then you've got to rewire your pins, which you can do very, very painfully, but it's possible.
Okay. So now that we have them plugged in together, I am going to complete the stack. It came, the frame here came with these little spacers, and I kind of like them, and I'm going to use them. They're just plastic. They're not quite like a too rubbery material, but you'll see that we're going to layer it with some more rubber as well. Because these gummies here, these yellow parts on both the flight controller and the ESC are rubber, so there's no hard contact on hard contact. And maybe you're wondering, why is that so important? Why do you want to stop the vibrations with all these gummies? Well, the motors spinning up are going to cause a lot of vibrations, and basically that's sending in noise to your flight controller. So it's not going to function, it's not going to read the data as well and give you the crispest flight. So if you can isolate it from your drone, it'll get a little bit better performance. And yeah, we're going to use the white gummies here. Those are going to go in between the nuts here. So we got the nuts that are going to hold down everything with these screws that are right there. The gummies in between. But let's finish this first. So there's our plastic stack. Very, very important. This can freaking hurt you if you get it wrong, or your girlfriend, like in my case. There is a small arrow on this chip. That means it's the front. That's right there. So I'm going to need to flip it this way because that's the front of the drone pointed towards me. If it's misoriented, basically this is like the little chips that are in your phone, and you know how you can tilt your phone and it'll do stuff, you know, flip the other way around. It can sense all that data, so if if it's already flipped another orientation, it's just going to build on the errors and flip out like crazy. So probably one of the most crucial steps is making sure your flight controller is the right direction. You can do this both manually, like I just did, or you can do it electronically inside of Betaflight or whatever flight control system you use. You can set up the orientation of the board both. Let's see how many directions they do. I know you can rotate it horizontally, or you can rotate it vertically, and it'll still read out the data. You just set it up the right way. I've done that in the past for one of my builds. And for now, we will just keep these fingers snug. You know what? Let's tighten them up just a little bit, because pretty soon we're going to be done with all of the bottom part of the drone, and we're going to be putting on the top. So let's just get that out of the way. Anybody got any questions, or do you got any comments, Bernard? Questions yourself, maybe?
No, you've got most of it. The only thing that I do differently from this build right now is I don't have the rubber pads in between the stacks, so I literally put an extra screw on there, an extra nut on there, just to as a spacer. Yeah, and stacks have changed over the years. It used to be you'd have to add in your own little plastic things in here, but now these screws are so long that it's just running. So you can see there my nice little stack there. And you can see why that's important. There are stuff underneath here that we're going to need to protect and make sure they don't touch. Do you have the diagram for your flight controller? Because I thought it was supposed to be mounted... No, that's right. Never mind, because I thought it was supposed to be mounted that way, but the USB is mounted that way.
Right. Yeah, I'm just following the arrow here, but it's definitely important that we check. I actually have another... let's go back to this thing. We can go to the next ESC wiring diagram. This is pretty cool. It shows a lot of extra stuff that you can put onto your build. Yeah. So you have your camera up there, your VTX. Now I want to spend some time here with the FreeSky receiver, because this is the one thing that I don't have the correct cable for the build, so we're going to leave the receiver off. Technically it will still work without the receiver. But you can see here, I'd want to mention that you want to find a good 5 volt, and also you want to find an S-bus pad, and you can see the one they have connected there. We can go ahead and move on to the next one, which is going to be connecting our DJI Air unit. I'm sorry, this is the CADX. We're going to be connecting the CADX to the ESC now. You can go back to the ESC, and it'll have a plug for the DJI, which is a couple slides. Yeah, is right there. Now you want to pay attention to that orientation. Luckily, our orientation is the same.
So sometimes for DJI pins, the orientation is weird, right?
Right. It's mostly standard now, because they're building these ESCs that have a connection straight to them, so it's getting pretty standard where you can just plug it in. You used to have to solder everything individually.
Oh, that must have been weird.
But yeah, so it's just important. You don't want to have 5 volt go into a signal and frying your over $100 thing. So just be careful when you're going through that step.
And with a regular non-DJI camera system, you would wire it into your flight. Your flight controller would have an on-screen display. So you wire it directly into your flight controller, then you wire it out from your VTX. So your VTX is your video transmitter. The CADX Vista just makes it nice where it puts all that into one block. You don't have to worry about wiring a separate VTX and choosing a separate video transmitter and camera type. It wires in one block. Yep.
One thing is, for your CADX Vista, you have to solder all the wires onto the CADX Vista. Now you'll notice, it might be hard to notice, but I have left one of the pads off, and that is the S-bus pad. Going back to the receiver talk, if we had connected that to the drone and we had a DJI controller, we could control this drone could be done. We wouldn't even need the receiver, because this video transmitter also works as a receiver, but we'll get into that later.
Okay, back to the camera.
Yep, so I done goofed.
Uh-oh, what'd you do?
You want to leave your ESC stack off until we get all the wires underneath that we want. And the one wire I forgot about was my camera wire. We're going to scoot this under here. And I got it flipped on the wrong way too.
Yeah, okay, your camera's the other way.
Yeah. So we're going to flip this around here. I like it going this way. Okay. So let's see, I think, yeah, we want it this way. Then checking our orientation, we're going to go this way. And we get our camera snug out here. And now I think that's going to be all of our wires for now, so we can mount our nuts onto the ESC, FC. And maybe a little discussion for what the flight controller, more about what it does, would be nice. First off, I need to find a screw. There it is. 2.5 I want 2. Yeah, so I went back there with a nut, and some of these long screws kind of came undone because of that, so we're going to go back and tighten those up a little bit. Something you need to watch for is all that. Okay. Okay, we got all the gummies on. Where'd that nut go?
You good? Did you lose something?
Yeah, a little nut.
Which one?
It's probably an extra one in here, maybe.
Okay. No.
Aha, there's an extra one.
Oh, you're lucky. It's probably on the floor.
Yeah, probably.
I'm not going to dig around under your pants. I'll check for it tomorrow.
Yeah. Be useless then.
Yeah, that's fair.
Unless you lose it. Okay. So we kind of went over all the connections for everything for the most part. Just once again, the one thing that this thing is missing is the FreeSky receiver. So the guy this drone is being built for doesn't have a DJI controller. We're going to use UART 3, which is going to be yeah, it's going to be right around there. But anyways, too small for y'all to see. So the next plane of attack is probably going to be the most delicate. And that is going to be changing out my camera. Let's see if this is a good size. Yeah.
The camera probably.
Thank you.
I had it pulled out while you were talking.
So here is the Nebula, which is also an HD FPV camera. That is, you can see, a micro. And this camera here is a nano. The reason I'm going to want to switch it out is because this has a fitter to make it the same size as that, but it's just rubber. So when I put a screw into that, it's not a good connection. So we're just going to get rid of this and get rid of this whole camera. We're going to go to the back and we're going to see these 2 screw holes here. I'm telling you guys, now it's going to get exciting. Trust me. This is pretty cool. So all these little individual wires, it's going to be quite a thing when we unplug it. Unscrew this thing.
I'll be right back.
Okay. or maybe not so excited. Oh, I think I'm getting it. Yep.
How we doing?
Well, this screw's being a little difficult. So here's what we might do, guys, for this camera. This I'm gonna do off screen for the guy. We're gonna go ahead and finish this build, and it's gonna look pretty well put together even with this thing. Like I said, it's gonna be the same camera size. It's just when it comes to flying this thing, you don't want your screws just in this rubber. Not good. And maybe I could find screws that are longer, but I don't. It's nothing like that came in the build. So next thing I'm going to do is I'm going to keep all of my little loose electronics that aren't screwed down like those. Put down. So my favorite tool is this. I guess that's more of a not a tool. What would you call it for that? Yeah.
While you're doing that, I'm casually reading a children's book.
Okay. So let's start with the big boy here, the unit itself. Once again, this is our video transmission. It could be our control receiver. It can do both. Oh, I'm so sorry, Bernard.
No, it's fine. We're doing okay, actually.
Okay. Yeah, we won't do that again. I think I got some scissors in it. But the reason I really like this X-Acto knife on these is because it's perfect for peeling up the red part. Oh yeah, and so this is 3M red tape, double-sided sticky tape. Definitely get the 3M. It's the best.
Most builds nowadays will require that you have a little bit of double-sided sticky tape.
Yeah.
So think about investing like $5. Or invest in 3M like $200 and see if they give you a free ticket.
Right, there you go. Alright. So we got it nice and snug in there. So the next thing is going to be my race wires I'm going to set down. Those are going to be a little tougher to get just right, but we'll try. Oh, there's some actual scissors. Can I borrow your actual scissors?
Oh yeah, go for it.
That's one of my body clipping scissors for RC cars.
Yeah.
Oh man. Are these, you want me to use those instead?
Thank you.
Oh man, I like these. Yeah, these are my body clipping scissors right there.
Wait, where does that big scissor come from?
They're right in there. You had two apparently.
Huh.
Yeah.
What?
Yeah, there's two in there.
Oh, it's probably James's.
Hmm.
It's probably my coworker's.
Alright, so you can see we applied the double-sided sticky tape to the bottom, and once again we're going to do this 4 times. But we're getting close, ladies and gentlemen. After this, it's the K plate and then the top plate, and we are done.
Yep.
One last thing would be mounting the antenna. I've had some ideas about this antenna thing because it's not really a plug and play sort of scenario. See, I can see this.
We will be covering how to actually get it all programmed and get it all ready to boot in a different workshop because we realize there's not enough time. Right? 'Cause we're running almost into 4 o'clock territory right now.
Yeah, and it's a good one to watch because it's got programming. It's got basically building is only half the step. If you can't program it right, you just got a hunk of carbon and electronics.
Speaking of programming, earlier today I was doing another class, and some of our students are programming their Arduinos to just shout at people. So it's fun.
They've been probably watching too much Michael Reeves.
Yep. Seems to be a common thing these days.
I want to do one of those like over-engineered projects for my capstone. Just something kind of funny, you know.
Are your capstones 2 semesters or 1 semester?
Ooh, 1 semester.
Because ours in engineering are 2.
Mm-hmm.
So yeah, it's gonna be tough for you. But if you want to, I'm happy to help if you want to build like a Stanford doggo. Stanford Papu.
Oh yeah, I had that idea for a while. That'd be fun.
I'll even bankroll it if I get it at the end. You build it for me and I keep it. That'd be fun. I don't even know if I can afford to bankroll it. Actually, I'm broke. Drones eat all my money.
Oh, did you ever build one of those props?
Which one?
Those foldable props? Did you ever assemble one of those?
One of these? Yeah.
One of these pulls out the ball. Done.
No, I got one of them. I didn't build all of them. Do you want them? You want me to just assemble them real quick or no?
That'd be fun, yeah, so we could show it off at the end of the build. Maybe.
There's one assembled.
Alright, and we have one more piece of electronic to hold down, and the last one really is the camera, which is going to be our next step. So, once again, one more of these red double-sided sticky tape from 3M. Oh, these are pretty cool. So this is where we're going to put
We're not sponsored by 3M, by the way.
Oh yeah, I just gush on it. I really like the double-sided sticky
fine.
tape.
3M's a good company. I'm happy with them.
Because I've tried other double-sided sticky tape, and when I found this thing, oof. Okay, I keep on going.
Nah, it's fine. I'll feel you. I'll leave one unassembled so that you can just put it together.
Yeah, 'cause I want to know what this is like. So I kind of skimped on this one. I didn't do the best cut job, but it'll do the job because it's 3M double-sided sticky tape, and it's the best. Okay. Or not. Come on, buddy. I'm just gonna do a new one. This is bad. One more try. Oh, that's right. We have scissors now. There we go. Whew. Okay.
Sure. Here you go.
Cool.
The last one's not assembled yet, so I'll put it in.
now we have that taken care of.
We have no audio, can't hear us. Oh shit. We've got that's an interesting problem.
Hello?
That hang on.
Oh, is that static noise?
No, that's us. Checking the stream.
Ooh, that would suck if it was the whole time. He said he was back at some point though. I'm just gonna go ahead and do this.
It's working on my end.
Okay. Well, obviously you can't hear us right now, but it's working.
T-Rex, let us know if you still can't hear it. But it should be working now.
So, we're going to take this build a little ghetto here. We're going to use some of this electrical tape here, because I'm going to insulate these, it's not really insulate, but just kind of tuck them in, these LED wires, a little bit. So I think the best way, the cleanest look is going to be starting here from the bottom. So I'm trying to strategically take out all the slack here and hooking it there. Let's see how this looks, if it looks ghetto or nice. Hopefully it looks nice. Just going to go with some of this. Well, you can tell my X-Acto blade's bad when you gotta stab it out. It's not the worst thing. It's definitely functional. So, there. Let's continue. Make sure you get it nice and tight when you're doing this kind of electrical tape work. Make it look just a little bit cleaner. Try to get it right here on the little edges. It's that extra little finesse. Last one. And I think once I do this, this is the last thing I need to repeat 4 times. So that's pretty fun. Hey, you guys missed it though, all the soldering joints I had to do. Whoo!
We wish we could cover soldering here, but due to the library, basically only I can solder in the library is the rule, and it would have been easier just to have done it before getting here. Yeah,
we were going to torture you with the whole thing, but the idea was to finish the connections to the ESC wires right here. You know, those little guys we were going to do on stream, but that's probably better for y'all anyways. There are, once again, there are going to be seminars for soldering in general if you guys are interested. Alright, now comes the most fun part, connecting your camera. So, you want to look at the writing of the camera. That usually tells you which way's up. So, the side with the wires coming out of it, that's actually going to be the bottom. So then you look here at this K-plate, very interesting. We can mount it 2 different ways. What I like is, I'm going to use this one here with all the holes. Yep, that's the one I'm going to use. So, I'm going to take, these screws come in the package, they're the camera screws, and I'm going to take these black O-rings to help us, I don't know if you guys heard me earlier, but this is too small for the K-plates, so this is going to help like added cushion to keep the camera nice and snug. Snug as a bug in the rug. Alright. So that's going to go on this side. Like that. Alright. So I have the right tool. This one is going to be a 1.5 millimeter tool. So usually you're just going to need a 2.5, a 2, and a 1.5 millimeter Allen key. Usually going to be the standard for building a drone. And look at that. I almost think that's screwed in. I hope I can get the other side like that, and that would be... Whew. May not have to switch out the camera after all. We'll see. It looks nice. Starting to look like a drone a little bit, guys. I guess it kind of looks like a drone because there's 4 motors on it. But starting to look like an Fpv drone, I guess. Okay. That side. And we are getting so close, guys, it's not even funny. After this, it's the standoffs. I really like the color for the metal for the standoffs. Pretty interesting. Oop. Of course, I'm putting the O-ring on the wrong way.
As you can tell, we are professionals.
Yep. I wish AJ popped in here so we could see his drone getting built for a second.
You'll probably watch the stream afterwards.
Yeah.
Hey AJ, have you butchered your drone badly enough? I'm kidding.
Yeah. You're welcome. It's gonna fall out the sky immediately.
Oh, don't say that.
Oh, it's desync. It's gonna be terrible. Oh, see, this is the problem. Is this camera is a little bit too small. That's okay. We're gonna fake it till we make it. But this definitely does need to be addressed before it goes out and fly. I'm gonna need to fix the camera, but we are running a little bit close to the time, so we are gonna push through it. Just get nice loose fit. Oh, I think I might have actually got something there. That's nice. Just pull out. Yeah. Come on. Very nice. Okay. I like this color, by the way. This orange. It's got orange on the motors. It's kind of orange. I don't know if you guys saw it earlier, but the ESC's got like that orange paint splash on it. I really love the color scheme of this drone. Kind of got like a little fire going on there. Alright. So now we're going to pull out our aluminum screws for the standoffs. These are the 3.3 M by 6 millimeter. Looks like these standoffs feel like aluminum. So we're gonna go switch back to our 2M. Or did it say 3? There's our 2. First standoff in. Man, I really like that color. I'm telling you, AJ, I might just have to buy this drone off you. Alright. Next one. T-Rex, please tell me you could hear us though.
I'm listening to it through my headphones. I'm hearing audio.
Okay.
So we should be good. T-Rex, if you're still on the stream, it's probably on your end. But I'll go back and watch it, and if there's any sections that are missing audio, I'll go and check.
We'll just start it over. From scratch. Right now. I'm taking it back apart, guys.
I'd just say go home at that point.
Oh, we peaked the levels. Ooh. So this is, yeah, OBS in the flesh.
OBS is good. It works. That's what matters.
So what you working on there?
Me?
Yeah.
I'm reading a children's book for the Harris County Public Library, but it's STEM related, so they want me to build something for it. So
Huh.
I'm building something for them.
Very cool. Two more to go, guys. And then we pancake this thing together.
I can hear you fine. Okay, cool. I was worried for a sec.
One thing I guess I can mention is what's so cool about these motor skids that we have is what their real purpose is to protect all of these screws. Is when you land hard on the concrete and run, you can wear down these screws so badly that you can't even unscrew them and repair your drone. So skids I recommend. You could 3D print them, or these cool ones that got the race wire and the LEDs on them. I'm figuring that they're gonna like kind of change intensity as you increase the throttle of the motors, which I think is pretty cool. But that's just my hunch. I don't know if it's gonna do that for sure or not. Alright, here we are on the last standoff. And I've dropped a screw for the second time. So we're gonna grab this one. Yeah, and then here's the top plate finally coming into action. It is going to be our last piece of the drone, and I'm going to do a quick mention on this antenna and show you guys a quick ghetto idea I have. Because, yeah, there's a couple ideas. So, once again, we're going to want to figure out the orientation. You can see the little outlines for the K brace again, like we got right up here for the camera. Call those the K brackets. So, on I go. So yeah, you're fitting in the K bracket because it's kind of sticking up. It goes right in there. You kind of feel along the bottom, make sure the bottom's all locked in place. And I'm feeling some resistance, so we're going to find out where that's coming from.
Left side on the right. The top side is tighter than the bottom side on the camera side.
Okay.
Just push it out a little.
Yeah. So this part's always just a little. There it is.
Building drones like building Legos.
There it is. So one thing we've noticed is, see that capacitor there? See how the capacitor's kind of almost hitting the carbon fiber? I don't like that, and I'm going to be working on that for a little bit
Later.
after the build, and we're going to make that. So don't try to have electronics rubbing like that against the carbon fiber. You always want to insulate.
Carbon fiber is a conductor.
Yeah.
So if you are building something if you are using developing some electronics and it's contacting the carbon fiber, whatever else is contacting the carbon fiber is going to be shocked. So you want to do your best to insulate the carbon fiber from any sort of electronics you have. Carbon fiber is a conductor. 3D printed plastics is an insulator.
Right.
Rubber is an insulator. The foam pads and things would be insulators. You just want to make sure that you're not contacting stuff with the actual board. Your ESC, sometimes depending on your frame, your ESC will have a little pad that you put before you put the ESC down to prevent it from contacting the board. This one has rubber spacers that prevent the same thing. But yeah, if you are old enough like me to have connected a CC3D board to a live, I connected my CC board to a PDB and then connected the PDB to the frame by accident, you will burn your quad.
Yeah.
Yeah. That was the old days CC3D. 2016?
I'll do y'all one better. KK2 board.
Oh god.
That was my first drone build. Was with the KK2 board. We're talking about these flight controllers here. The thing that's on the front, the top stack here. Basically, it's like the brain of the drones. His is the like we keep on talking about the software, like the coding that you got to do for the drone. His program no longer exists even, so you can't even really work on them that well without having.
So we're talking about history of flight controllers because we all started in the old days, and some of these flight controllers are crap and still don't exist anymore.
So mine, it has a programmable buttons and a cheap LCD screen, so you can still program it just with the buttons. Pretty cool. They don't use that anymore. You program them on the computer, plugging them in. Or
Libre Pilot still exists now, so they've made a version of Open Pilot for CC3D. But
you're right. Yeah, I have that on my computer even.
But CC3D now can take Betaflight, although
yeah.
that'll be impressive if it works on Betaflight.
So here we go, the final two screws, and we're going to stop. We're going to segue into this antenna, and then we're going to finish it off with a quick discussion about what's HD video.
Yeah. Because we're running short of time.
Okay, so I have an idea for this antenna mount. It came with this kind of plastic doohickey you kind of see connected to it. This can be removed. It's kind of just a friction fit thing there. My idea, I tried putting a, let's see where I can find one of those. I tried putting a zip tie through the holes. The holes are too small, making me think that maybe you can put one of these camera screws through it. So we're going to try this idea real quick. Okay. Flip it over. Wow, look at that. It's a built drone now. Okay. So we want the 1.5 millimeter Allen key again. Working with these camera screws again. But this time we're trying to work on the antenna. So the idea is the screw will go through the bottom and maybe this will actually hold together. See, this is not the best thing because this antenna is sticking out of your drone, and so it's going to be the first thing that contacts the ground. Yeah, and there you go. This screw, the camera screw won't even go through the carbon fiber. So yeah, this is probably your most vulnerable part, so you want it to be kind of flexible, which is going to be my next idea. So yeah, like I said, these zip ties won't go through these small holes here. So we're just going to try to wrap it. Oh yeah, be careful that we don't want our battery to be inside the loop of this zip tie. We don't want the battery wire to be in this loop of the zip tie. And I'm going to try to get it on top. Oh, nope. Get back under there. Okay, yeah. Okay, yeah. It's an issue. Yep, so this is just an experiment. I don't like how it's going already. We talked about earlier how you don't want electronics touching the carbon fiber. Very small insulation on this antenna wire. Rubbing up against here, no good. The solution to this is a 3D printed mount onto your frame here. You'll see that there in the next video, hopefully. AJ, the owner of this drone, works for a 3D printed company, so I'm sure we'll be able to get all the 3D printed parts we need for this thing. Now, speaking of this antenna and the FPV system, I would like to end this on really what is this FPV system that we're talking about, HD and all that. Is that really that big of a deal? People have had HD TVs for a while, right? So,
I got it.
Thank you. So you can see there on the left the digital HD system. There are two main benefits. Is the quality is better, and also there. In this scenario, you see a guy flying indoors on a racing track. On the right, we call this extra distortion multipathing. There will be like lines going through your video, and you'll see static. And that's actually eliminated by the digital systems. When you do start losing video, you'll get blocky images, but you'll know when you're getting to your limit, and you can turn around. Same with analog. You'll know your limit and be able to turn around, but I think you can go farther with digital. And so it's just for y'all that have never flown FPV before, you can see the difference right there, what it looks like. And in the past, people have been like, oh, this video really isn't that good. But now, put the goggles on someone, it looks pretty darn good. It's about a 720p going to your goggles. You know, when it's right up at your face, it looks pretty amazing. So, let's see, how do I get to the... Well, anyways, guys, can you get it back to the camera here? Ooh. How do I get to the camera again? Oh, there it goes. Okay. So, y'all have watched me build this from scratch, minus all the soldering components, and I hope you guys learned something today. Is there any questions before we head out?
All right. It'll take a minute for it to stream up, so questions usually have a 30-second delay.
Right.
Yeah.
There it is, guys.
Yeah. Can you believe it's that easy to just build stuff in an hour?
Yeah. And honestly, guys, for the soldering, it took about an hour 30 minutes. Maybe 2 hours. Here's one fun note, guys. Not anybody that stayed along for the end. I made a boo-boo on the build. Oh, that's something else I can talk to you guys about is what's this little plastic stuff over here? This is called heat shrink wrap. And it's something that you do after you're done with the soldering to insulate your build. Well, I went to cut the, remember I said you have to cut the length of the motor wires, is I cut the length too darn short. So I had to unsolder that wire by cutting off the part of the heat shrink wrap, and I had to solder a new length of wire on. So there's the one boo-boo in the build, guys.
But
anyone
yeah,
that sticked around.
I think
It works fine.
I think that's all of the questions.
You know what? One last thing, guys.
Oh. Whoa.
Smoke test.
Oh, the smoke test. Alright. Hey, we'll get the fire extinguisher.
I'm just joking. I've already done it. It works. But yeah, you'll be able to hear the beeps and everything. Yeah. Yeah. So there you go.
It's missing the secondary beep.
Yeah, that's because it's not programmed yet.
Ah, yeah.
So we still got to program it. That's going to be the next build, guys. So stay tuned, and you guys will learn how to program this thing.
We will see you guys next time. Next week is the autonomous drone workshop. We won't be covering anything like this. It'll all be theoretical. I'm so sorry. Have a good week. Stopping recording.